Hello and welcome back to Farmyard Academy. So I've got another video here for you today looking at electrophilic substitution mechanisms. So we're going to go straight into it, and what we always have to do first when we're doing electrophilic substitution is to make the electrophile, and you have to produce some equations. So first one, we're going to look at concentrated nitric acid and sulfuric acid reacting together. So it's H2SO4 plus nitric acid, and what happens is the sulfuric acid, which is the stronger acid out of the two, forces the nitric acid to behave as a base. And if you go back to Bronsted-area, base is a proton acceptor, so the HNO3 is going to accept a hydrogen and the H2SO4 is going to give up hydrogen. If it does that, it becomes HSO4 minus and it becomes H2NO3 plus. Now the H2NO3 is unstable, and what that will do is I'll further break down into water, so you can show it via another equation over here. So it will break down into water and NO2 plus, which is your electrophile. So electrophiles are electron deficient species, and that's what's going to interact with the benzene ring. Okay, and then we'll show the mechanism. So we've got benzene, which is C6H6 with the delocalized ring system, because each carbon has a vacant p orbital, and then what this is going to do is it's going to interact with the NO2 plus. So your first arrow where there are electrons to where there's no electrons, so from the ring system to the nitrogen atom. And then we're going to draw out the reactive intermediate, which is a horseshoe, and what we've got to make sure is that our ring does not go beyond carbon 2 and carbon 5. So put your plus in, and then you've got your NO2 attached, and you've got your hydrogen, and then what's going to happen is you're going to lose a hydrogen to reform the ring system. Okay, so overall hydrogen's been substituted for a nitro group, and really easy to name. So this one, nitro, and then you've got the benzene ring. So overall, nitro, benzene. Okay, so that's it. So next one, we're going to look at Friedel-Crafts, and that's all to do with aluminium chloride, so AlCl3. And then this is going to interact anything with the chlorine, so you can react it with haloalkanes, you can react it with acyl chlorides. Basically anything that's got a chlorine atom will interact with the aluminium chloride. Again, start with an equation. So AlCl3, we'll just do chloromethane, so plus CH3Cl, and this AlCl3 is going to take the Cl atom, so you're going to be left with AlCl4 minus plus CH3 plus, and again, because of the positive charge, this now becomes the electrophile. So this is going to interact this time with the benzene ring in exactly the same way as the nitro group did. So first arrow from the ring to the carbon, 1 mark for that. Then you're going to draw out your reactive intermediate, your horseshoe again, like so, positive charge, and you're going to lose a hydrogen for the final mark to reform the ring system. So like that, and then name it in exactly the same way. For this one, methyl benzene. And that's it. So electrophilic substitution, nice and straightforward. See you on the next one.